All right. Testing one last time. Nicole, can you verify if you hear me now that we've actually
We're
started?
loud and clear and ready to go.
Perfect. That's what I like to hear. Okay. What time are we at here? All right, got just about 2 o'clock. See, folks are logging on. We'll start here in just a minute. Okay. See. All righty. Okay. Well, I'm going to go ahead and get started here. And folks, as they have time, of course, we'll be logging on, I suppose, as we carry on here. Thank you all so much for taking the time out of your day. I know there's plenty going on as the world of network installations and is booming. I'm certainly seeing a lot of activity on our side in the physical layer, and as I see just industry reports and even listen to our customers, there's quite a bit going on everywhere, it seems, and more to come. So it's an exciting time to be a part of this industry. I thoroughly enjoy it and glad to be here and present this to you today. My name is Lucas Mays, one of the associate product line managers for the fusion splicing products here at AFL. So we'll cover a really kind of a wide variety around ribbon technologies and enablement, and maybe hone in a little bit on the splicing, since that's my bread and butter. But hopefully this is a bit more of a holistic approach and beneficial for you all to see kind of what's happening on the physical layer side of things, at least with fiber, and what's being done to enable, deployment and ease of installation with what's going on in the world around us. So without further ado, I'll get started. And as you have questions, one last housekeeping, if you have questions, just go ahead and throw those in there. And, if it's sensible for as we're going through, I may even stop and answer a question if that makes sense. If not, I will hold them at the end. We'll kind of reserve some time at the end specifically for questions. So no worries if you don't get it in during the middle. But again, I'll kind of just stop and answer if it makes sense, or hold to the end if I don't get any. So without further ado, we'll get started into the content we have today. So just the way it is, not in a bad sense, but of course our circumstances have certainly changed. We've all had to adapt. There's been a lot of activity over the past, year and a half or more, as we've been dealing with the challenges of our day. And maybe some of you can relate to the, situation represented here. I know I certainly can. When you wake up and grab your coffee and sit down, and your commute to work is, 10 paces down the hall, there's certainly different things to think about than what you're used to sitting in the office. And maybe some of you even more so can relate to the second image here. I personally have a 4-year-old and a 2-year-old, and I relate to this one very well. Many a days, my son, doesn't quite understand what work means or what focus time means. And so, daddy's there and, well, daddy, let's play. But anywho, in spite of all that, of course, the data demand for work from home situations, remote situations has certainly increased. And again, we've all had to adapt and do things a bit differently. So during and kind of, post, I don't know if they post yet, we're things are, of course, changing even since the few weeks that this content was generated. But digital services certainly grew at a phenomenal rate during the pandemic, and a mad rush to leverage these services, especially in the beginning and in the midst of it, to maintain productivity as much as was possible during these just strange times, was paramount, especially for, when you're not able to be physically together. So, we look at continued growth as we look to, again, potentially exit, hopefully exit, or depending on what happens, if we continue to maintain. I know things are very volatile right now, but this chart here is a representation of what has grown, certain digital services that grew throughout the year of 2020 and even thus far into 2021. And so this isn't a chart of, what was like the most common digitally used services, but the growth rates, right? So we saw a 95% growth rate as in desktop as a service. Kind of makes sense, right? Everybody's going home. They may need something more powerful or more, they don't even, as chip shortages and things have even hemorrhaged the ability to purchase consumer electronics. Maybe you needed something to be a virtual desktop for you while working at home. And so you can kind of see across the board there, the different digital services, and that the total market in 2020 grew by 6%, in 2021, 18%. And, so again, just kind of talking about that increased bandwidth desire and needs. So this is another chart kind of looking at it a bit differently. So this is kind of graphing or showing spending, total IT spending in a few different categories: data center systems, enterprise software, etc. And so spending was down during and at the height of the pandemic. As you see from 19 to 20, the spending certainly seemed to decline as there was just a lot of instability and fear of what was to happen. However, into 2021, spending rebounded pretty quickly, especially as you see that little the light grayish bar in devices. Devices spending, skyrocketed into 2021, and so total IT spending as a result. And there's a catch up for the pandemic demand and data. Government stimulus trying to boost the economy, and so a number of reasons. As we go into 2022, we may see a little bit of slowdown. The rate at which it grew from 20 to 21, I don't know will continue at that rate, but I would certainly expect to see still growth and continued spend as these services and digital capabilities seem to be a mainstay looking forward. So how do we address some of these changes, or maybe I should say specifically, how do we address them from a physical layer side of things? There's of course a lot of software developments going on that are the higher layers of communication protocols, but at the physical layer, which of course is where our focus is today, how do we address these? And so we've seen a transition to a fiber deep network architecture for many years. Of course, it was very much a head end fiber node coax, at least in the many years ago, and we've transitioned to getting fiber closer and closer to the premise or the end user. And so as we are now in this era of PON networks, DAS networks, things of that nature, we continue to see that fiber getting closer and closer, penetrating further into the networks. And so things like Wi-Fi 6, 5G, fixed wireless access, DAS, as I mentioned, these are certainly drivers for more fiber due to physical disaggregation and short reach access points, wireless access points, and radio access networks. And so some of these devices that, service the higher bandwidth, higher data rate needs are, shorter in reach due to the frequency spectrum that they're using. And so we've got to have more nodes, again, no more access points, if you will. And so that's, of course, going to drive more fiber delivery to connect all of these together in the various networks that, will be connecting them all for our usage on the premise or user side. So this is going to drive, the term that we use here, a converged access network. So there's kind of this new bridge between network applications where, this simplistic diagram kind of talks about or shows maybe a sense of the various levels of interconnection or intersection that, data service is going to various applications, various use cases from corporate level, big scale to small fiber to the home, but yet many of the pathways for that communication will be intersecting, overlaid, redundant, things of that nature. And so, the service providers themselves, either building these networks or even digitally servicing them, if, you're leasing fiber, of course, have, a wider variety of applications to serve on maybe the data lines that they traditionally only served a very small or the same types of applications. So this different types of traffic going to more endpoints is really what's kind of leading to this, what we call converged access networks. And so this is, of course, going to drive fiber density throughout the network, overlaps closer to the user for low latency or high bandwidth or both, depending on the application. I mean, when you start talking about smart cars, remote surgeries, and these are, of course, it's certain in some ways some of the dream applications, but there are certainly applications that money is being poured into today. I even saw recently a remote tattoo artist using 5G as a means to do a tattoo design on someone in real time. That's pretty interesting. So for the rest of our time here, I'll just give a quick breakdown what we're gonna discuss again from the physical layer, and really to address what's going on, what we've briefly talked about, in that networks built around ribbon fiber save time and money and are better prepared for the future. And of course, how relevant that statement is to you is there's a lot of variables that go into that. So, of course, you press it too hard, or depending on the application, it may have varying levels of benefit to you specifically. But however, at large, we certainly see ribbon fiber being a huge enablement for, speed, time savings, like that. Technology changes to cable connectivity, splicing, and even testing. We'll look through all of these to kind of see this connectivity from A to B and how some of these changes are actually saving us time. And then we'll review some time studies conducted with some of these latest technologies, looking at like butt splice or mid-sheath entry scenarios. So really from like an installer, and even patch panel splicing. So from an installer or maintenance type of perspective on these networks, what kind of time savings are there with some of these newer technologies? So to start our story here, looking at connectivity A to B, we'll call it a campus LAN environment. So this is, of course, a simplified example. Your day-to-day applications may be bigger, depending on where you're joining us from, and maybe smaller. I kind of almost envision like even my college campus, U of L, University of Louisville, go Cards. My alma mater example where you've got a campus and you're servicing various buildings, but in this case, we're going to talk about building A here on the left, building B on the right, with some, of course, span of cable between to connect the two of them, and then whatever, of course, cable even would be connecting to the outside networks. And so from A to B, however, you're going to have a variety of needs to connect these two. Of course, once you're inside the building, if you're outside the building, as I mentioned, connecting to the external network, or even multiple buildings within the network, if you have to make network branches or splits, when you actually go to, drive and put the cable into those pathways, what kind of pathway are you building out for the cables? Is it direct bury? Are you actually going to have a duct system? And again, that's going to depend on your needs and your application at your campus needs at the time. And then when you go to break this out again, splicing, how are you actually connecting it all together? And then lastly, how am I verifying testing this network? So we're going to kind of walk through really all of this. So from the cable side, we look at these latest generation ribbons. So that's kind of the core, right? That's the fiber inside the cable, and then the rest of it is just packaging. This fiber, the ribbon, is where the data is, and on the passage side anyway. And so this latest generation of ribbons, what I'll call collapsible ribbons, promotes use as ribbon or loose fiber. And so you can see there as you kind of stretch or pull these, it behaves, and you can see that it is bound together. And when you kind of feel it, touch it, go to splice it, it's a ribbon, but you can also easily hand pick it apart to splice one fiber or to test one fiber. And so even repairs might be simpler in that case. If you've only got one line down, you might need to, just break out one. You can do so with your fingers rather than additional tools or steps. And then the biggest thing, however, with these types of ribbons is the maximizing of space in your cable core. So which we'll show a bit more in a minute, but just the density that you get out of these, that being able to act like a loose single fiber stranded cable, even though it's a ribbon. So I would say there's clear organization that we kind of see with these collapsible ribbon types. This is an example of spiderweb ribbon, AFL's variant. But in general, I think it's easier. I've seen the markings on these. So from an installer standpoint, it's easier to identify and sort which fibers, which bundles you're actually going to be connecting together. And so even just talking about those day-to-day time savings and actually doing all the pre-prep work before I actually go to splice or terminate. And then, as I mentioned, maximizing pathway. So, not having to consume as much real estate in the ground or in the building once you go to route these cables, just due to the sheer reduction in overall size and weight. Weight being a big one too, especially once you're inside, for these cables built around this ribbon technology. And so here's kind of an example of the, this is of course blackjack at OSP, but you get the idea really here is that, look at your traditional loose tube type cable up the top, your central core strength member, buffer tube style cable. And then as you kind of work your way down, you see, okay, mid row here, that's my ribbon, and, central core, central, loose tube, or sorry, not loose tube. There's a central ribbon, and you see strength members just outside of that central tube where the ribbons are. And then you kind of, draw that design out and we see that. But then again, compared to down the bottom, these wrapping tube cable with spiderweb ribbon, and other examples like it, we see the reduction in cable diameter for similar fiber counts. And so pretty drastic. Again, a lot of weight savings. You get more fiber, more cable on a single reel. And again, just saves me a lot of, when I'm determining site specifics, pathway specifics, certainly some savings there. So I would say it's no longer just an outside plant product. So these collapsible ribbon fibers first were seen in black jacket cables. Obviously, that's from a sheer mileage or quantity standpoint of cable, that's the most. And so that's kind of why we saw that there first. However, these collapsible ribbons are being seen in various inside plant cables and indoor-outdoor options as well. And so now you can kind of take that value in the cable side of SWR or others like it, the collapsible ribbons, into the premise, wherever you might actually be, bringing it into the building and routing it in the building at. So, this can eliminate a transition splice concern, or even the need for added frication tubing. So, a 900 micron to 250 transition splice is something that I'm sure folks are very familiar with, those that are, actually doing the installation and terminations out there. And so, when you have this SWR or collapsible ribbon technology, you kind of mitigate that. And so it's just a step that's no longer needed to manage with, again, additional frication tubing, or splice prep steps. And so it's just a more seamless transition once you get into the building. Quicker sorting, routing, splice prep. So no buffer tubes in the outside plant and even some of the inside plant constructions. There's kind of various ways you can order it, on the inside plant. There's, subunitized and non. And so especially, from my perspective, if you go with the non-subunitized, both in inside and of course outside plant, then you don't have any of that additional cable prep steps to actually join these two and connect together. And then in addition, the gel-free, regardless of the cable construction, so buffer tube, subunitized or not, the gel-free dry is a huge benefit. Those of you that have done splicing for a while know how big of a pain and just mess that gel is, and cleaning it, of course, you get more efficient as you do it more, but it's still just extra time, hassle, what have you. So if I can get rid of that, I'd certainly try to. And then I mentioned already kind of the clear ribbon markings, some of the text on some of the encapsulated or clear covered, ribbons. The traditional style ribbon, of course, has been, utilized for a while. Sometimes the text was hard to read, rubbed off, what have you. And so I think these hash mark systems that are on these collapsible ribbons are easier to decipher, at least in my opinion. And so then you also are sorted by these, instead of the buffer tubes, you have colored binder groups. And so in these higher fiber counts, you kind of have the breakdown of, different binder groups, and it still follows the same color code, and love, and then has the different, the 1 through 12 hash marks, depending on, how many bundles and, how many ribbons are in each bundle, in each binder. And then, I'm not going to break down the chart at length here, but, again, hopefully you get the point of, it's just when you see one of those things, I think it's probably easier to understand how I think it is easier to sort these, prep, identify, what have you. So now even looking at the closure side of things, so even closures have certainly seen some updates. And again, some updates with closures specifically targeting some of these ribbon enablements. Improvements to density, with the understanding that ribbon fiber is, of course, enabling that density. So specifically a collapsible ribbon. So the transition tubing is one, for example, that's certainly not a necessity. It's still an option. You can still do that if needed, but we have various examples with some modern closures. The Apex closure is what's being kind of shown here, where the transition tubing is not there. And I mean, you can of course have 15, 20, 30 minutes just in transition tubing setup time, depending on your fiber count coming into your closure. And so then even when you look at the trays, so double stacking of ribbon splice sleeves is a big benefit, again, to density here. So rather that's traditionally been something, maybe available for single fiber splicing, but not ribbon splicing. So being able to double stack ribbon splice sleeves in a tray and fully populate a tray with double stacked ribbon splice sleeves, huge increase to density, double. And so this is, again, just improvements being, targeted around enabling of high density and less requirement for additional breakouts, bigger closures, things like that. So this next one here, not so much specific to ribbon, but since it kind of ties into the closure developments or benefits here. So some assembly seal improvements. So basically cutting out more fluff, more step, cutting out additional work in the entry and sealing of closures. No need for a screw. There are no individual screw removals. There's a depress latch, and you simply remove the wedge, as you kind of see depicted there. Pretty simple. The little white latch that you see there is kind of what's pressed in and then pushed down, and then the wedge kind of just pulls out, and that's what then gives you access to pull it, put your cable into the closure, and then to seal it, it's as simple as putting that latch back into the wedge that it came out of, and then clicking that white latch back down so it's snapped into place. And then there is just a simple screw that you see depicted in this bottom right, that after the cable kind of snaps in, this gel seal is what's compressed and provides that water seal around the cable jacket once you've put the wedge in place and tighten that screw down. So just far less steps, far less complexity whenever it comes to adding in, installing a network or adding in cables to a network, making a branch off of a ring, what have you. So then connectivity at the panel. So now we've now transitioning from outside plant to inside plant. So a traditional patch panel, of course, would consume a lot of real estate, a lot of rack real estate for slack storage, for splice trays. You had your panel maybe up top, but then you kind of had your slack and extra storage, some 4, 8 RU rack units below the actual panel for just, again, slack storage. So you consume a lot of real estate for, maybe not so many fibers, depending on, the solution you have. The LGX 118 is a bulky form factor compared to some of the newer proprietary designs. Everybody's kind of course, doing it a bit differently, but in general, density or shrinking down the size is the name of the game. And so much smaller than, again, the LGX 118 form factor. And once you, of course, shrink down from that form factor, there are options like these cassettes that maybe you've seen offerings of. This is, of course, AFL's Ascend product line. And there's, of course, others like it. And this, cassette options come in both fan out cassettes, splice cassettes, conversion cassettes, patch cassettes, taps, and I think even some XWDM. And then there's developments going on for other cassettes, even more than what's listed here. So you get a lot more versatility once you kind of come to the panel. As you look at some of these higher density, especially ribbon, kind of geared towards ribbon cassette designs, cassette and panel designs. And again, so then now ribbon pigtail, MPO, preterm cassettes certainly makes trunk cable terminations a lot faster. You're doing less, even if it's a preterm, you're doing less connections based on a ribbon or MPO. And then if you're splicing, you're doing less splices because you're doing a ribbon splice as opposed to singles. So when you come to even looking at termination at the panel, so you have options like MPO splice-on connectors. So splice-on connectors in general, single fiber, but have certainly gained popularity as the premium for a splicer, especially these active clads and more budget splicers have come down, and so there's not quite the barrier to do splice-on connector terminations there once was. And so we can even transition that now to a ribbon platform where, I have an MPO architecture, at least in my trunk, to simply, lessen the time to either terminate myself or to, if it's a plug and play preterm solution, to, plug in as many fibers and I can kind of have a conversion cassette if I wanted, if I'm doing a preterm solution, and break out to my LCs on the front end, or LCs, SCs on the front end. And so, then on my backside, if I'm going to do either, I can do either, as I said, preterm, or even like a bulk cable scenario, where I'm sure many of you are familiar with the fact that when you get a build out or you go to spec a job and you kind of have the layout of where you're trying to make your estimates on cable runs and where closets will be, the space allocated in those closets. And then, however, when you get to the site and you got to actually put things in place, it doesn't quite pan out the way it was originally planned for. And so that's where like a bulk cable scenario might make sense for you. So rather than kind of having, pre-made lengths of trunk that then may not work, you can kind of have a bulk cable. And so then you spool off whatever you need, splice on your MPOs, if that's the form factor you choose, and break out into your single fibers. And then even if you don't splice onto MPOs, maybe these splice cassette options, again, this is, you bring in your trunk cable, you've got your cassettes, as you see here, this is a splice cassette with LCs on the front, 12 fiber. And so you're just going to do a quick ribbon splice for each cassette. And then you've got 12 fibers per cassette, much smaller density. Then again, that LGX 118 form factor consumes less rack real estate, kind of maximize space within that closet, or CO or what have you. So then a little bit kind of onto the MPO connector. So we've seen the MPO connector, that form factor, that's of course leveraging a ribbon typically, from a data center type of connector only used in that space. However, now we see it, of course, in central offices. MPO trunk cables, of course, being used in parallel optics to QSFPs. That's, made its way from the data center now into the central office. And then even on the outside plant side of things, we're starting to see hardened MPO cables. And again, where fiber counts are growing. And so, being able to base on a 12 fiber, passive architecture makes sense. And so then we have these hardened MPO connectors that allow us to do some kind of preterm solutions, maybe in the field, or at least, quick install test type of solutions. So with that, there's on the testing and inspection, again, when you kind of get to that network verification or certification side of things, there's technologies enabling speed on that side as well. So, there are multi-fiber inspection scopes. So if inspecting is written into the job you're about to handle, or it's a step required in anything you're contracting out to be built. So these in-face images can be pulled up on these multi-fiber inspection scopes. This is AFL's Focus Lightning as an example. And, less than 2 seconds to get the full in-face image, and then only an additional, 1 second roughly per fiber to give you an in-face pass-fail analysis. And that's going to be, of course, according to industry standards. So you can kind of do the full in-face view real quick. And then if you want to actually have that certification of every single fiber and tie that into your closeout package, that can be done, 12 seconds per MPO, very quickly. You can also look at single fibers if that's needed. There's different adapter tips to accommodate both MPO and singles, with the same unit. Of course, cleaning is vital. Just because something's new out of the box, that does not necessarily mean clean. You've probably heard that said many times. And so then when it comes to cleaning, of course, we have one-click cleaning solutions. You're probably familiar with those, especially on the single fiber side, but MPO solutions exist as well. So cleaning out a port of MPOs, whether it be from the back or from the front, wherever you need to clean, of course, both bulkhead and connector tips available on the same one-click, same as you're probably familiar with on the single fiber side. And, so MPOs of 12, 16, 24, 32, one-click options available. And so having, again, just that quick, in and out clean for each port certainly simplifies the cleaning process. And even when you just look at, if I can build an MPO form factor into my network scheme, then, when I go to actually clean or inspect, or as we get to test later on, I'm getting, every time I push and click that cleaner, I'm cleaning 12 fibers rather than a single fiber. And so just the number of manual steps, you can kind of imagine somebody sitting there, click, 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 click. Again, just time savings kind of across the board when you increase this density with a ribbon solution. And so this is just another example of some other options as far as cleaning goes, cleat tops, and then there's various single and multi-fiber cleaning solutions with these cleat tops as well. These have actually been around for quite a while, mostly used in kind of lab environments, production environments, maybe where ribbon has been more sought after previously. So then my personal favorite, putting it together with mass fusion splicing. So I would say that splicing quite literally puts it all together, assuming you're not using preterm. And so, of course, when I lay in my cable and I put in my racks and I, have everything in place, I've got to actually join it all together. And so that's where I think the beauty of splicing comes into play. And so, splicing 12 fibers per single arc or per burn versus one fiber per burn, you can kind of get why that might be a lot faster, even with a little more prep time, simply because a ribbon splice, is a little bit more time consuming on the, strip, clean, and cleave before you splice. But again, nothing compared to the strip, clean, and cleave of 12 individual fibers. So improvements in automation, ergonomics, ribbonizing, fiber quality, all of this kind of helps drive the message and capabilities of mass fusion splicing. And so where, maybe I'm getting ahead of myself, where in the 90s and the 2000s, mass fusion splicing certainly meant a loss penalty. That was the kind of industry understood penalty if you wanted to get this speed with ribbon splicing, and you were going to maybe pay on the loss sides of things. However, as we've got some data that we've published in industry forums to prove, that's not necessarily the case. And we've even got continued studies going on with some even different fiber types that we're seeing out in networks being deployed today. You can see this, what's circled in red here, the average splice loss. This is a variety of different fiber combinations, different manufacturers, different ITU specifications of fiber. And this average loss, .03, .02, if you didn't know any better, you might look at your traces and think it was core alignment spliced. And again, that just speaks to really the improvements in fiber quality, even the improvements in the splicing technology, precision made V grooves, the basically ease of use of some of the prep tools that make repeatability and precision with ribbon splicing more, just easier than it used to be. And so all of this kind of combines to drive, again, if I can get these kinds of losses throughout a network, ribbon splicing, then, no, why wouldn't I? Might be the question that I would ask. So some enablements, I mentioned splicing technologies that, of course, enabled some of this outside of the fiber quality. So cleanliness, of course, is a vital aspect when it comes to mass fusion or ribbon splicing. And so cleaning those V grooves is very important, or keeping them clean. But, you all know, of course, the variety of environments. I've been in certain ones and seen plenty of pictures online of the holes and dirt patches that splicing has to happen. And so cleanliness is, of course, challenging, but it's still vital. And so being able to clean your V grooves, clean your splicer quickly is of great benefit to maintaining those low splice losses. And so you can kind of see here as an example in the 90R, the latest generation from Fujikura AFL, is that you can remove your V groove from the splicer. You can even remove the electrodes. So not pictured here, but the little black thumb screw you see there is just a thumb screw. Electrodes pop out, and you've got this little V groove block. And so cleaning your V grooves outside of your splicer, of course, means you don't have to be quite as, fine motion, careful, cautious as, when it was inside the splicer. And that's the only way you could clean it, because you're being careful of the electrode tips or the cameras underneath. And so you can kind of take these out of the splicer and clean them outside of. Just makes it easier to clean quickly and vigorously. And then again, pop these things back in if needed. And then even the 90R comes with a spare set of V grooves, so you don't even have to clean them necessarily in the middle of a job. You can, pop in your spare set of V grooves, keep on splicing, and then clean them whenever the day's done, and you have a bit more convenient time to do so. So there's also some application versatility that the latest generation of fusion splicing gets you. Again, particularly looking at the 90R here. So 200 micron fibers continue to be used in both stranded and ribbon cables. The 50 microns in reduction on a single fiber probably doesn't seem like a whole lot, but when you sum it up over the course of 144, 288, 432, even, especially higher fiber counts of 1728 and above, the density savings are pretty apparent. And so that's certainly one of the reasons this 200 micron push is happening. And so initially, single fiber splicing was the only solution for 200 micron fibers. However, there are, solutions today, and then we kind of have a full gambit of ways to handle various 200 micron ribbons, both single stranded and ribbon. And so fiber handling and V grooves to kind of mix and match depending on the application you have, all within the same chassis, the 90R chassis, if you will, certainly gives you that versatility and kind of confidence to tackle any job you might run into, and any, if you're from the designer standpoint, any kind of cable design or choices you might make, there are solutions to handle whatever might best benefit you on that side of things. So even when it comes to stranded fibers, so strides and ribbonizing is what I say here, but ribbonizing was traditionally only a service provider operation where they're taking, higher fiber count stranded loose tube cables, outside plant cables, and making a temporary 12 fiber ribbon out of those and then splicing. However, we've seen rising fiber counts even in the enterprise. And so as we talked earlier, the fiber is just penetrating further and further, and data rates and bandwidth demands are going up. More fibers are being utilized to service those needs. And so, then you start looking at, there it is. This is an example of what we call the RT02 ribbonizing tool. And so there's a lot more field friendliness to this tool than previous ribbonizing tools. You had to, there's a paste and there's an application process for that paste. The paste itself is considered a hazardous material when it comes to shipping, can't take it on a plane, technically. And so, and then even a cure time, there's a cure time associated with that paste. And so, this tool, this capability takes out all of that. And so you're able to get your 12 fibers in this tool, collapse them, put them directly into your fiber holder, and do your splice. There's even a color code assist. So folks that are newer and maybe don't have the color code quite as, memorized, there's that help there depending on the fiber holder you're using. And so just kind of the enhanced field friendliness of this ribbon tool combined with the rising fiber counts, folks are going this route to mass fusion splice stranded cables, whereas they might have traditionally done single fiber splicing. So now, look at the data. So I would say that new toys are all well and good. So we've kind of been looking at some of the new toys around ribbon fiber, but is there any substance beyond new and shiny? That's something I certainly look at when I go to buy anything, even personally. It's like, plenty of good sales pitches and salesmen out there. However, when rubber meets the road, is there actually something worthwhile there? So we did a couple of internal studies, and we've got plans to do more. We conducted some fiber to fiber splicing, fiber to cassette splicing, so kind of simulating a butt splice, a mid sheath, and even that, kind of at the panel termination scenarios. And so we did a traditional loose tube single fiber splice, so kind of the baseline traditional splicing or installation scenario, compared to loose tube with ribbonizing. So maybe taking legacy types of cables and designs, but then ribbonizing to utilize this latest generation of ribbonizing tool and still ribbon splicing. And then lastly, the most, advantageous from a time saving standpoint, just mass fusion splicing some of these collapsible ribbon cables and some of these, ribbon enabled accessories, panels, things like that. So for the studies we did, just a little bit of detail, we started the stopwatch after breaking into the outer jacket, the initial outer jacket. So buffer tube entry, gel cleaning, cassette assembly, loading into the tray, or the cassette where applicable was kind of included in the time that we took, that the times I'm going to show you here in a minute. So we would say a technician of, maybe average skill was used. So, times may, of course, vary slower or faster depending on your operator's abilities. So, we don't by means say that this is the Bible. Of course, there's a variety of skill sets out there. And so, but as a base level to kind of understand for a given operator, we should still see improvements, right? So looking at this here, this is the fiber to fiber splicing. So this is my butt splice or my mid sheath, branching off to a network leg and, splicing to another cable. So if we look at that single splice, we kind of did 12, 24, and 48 fiber counts. And so we look at that just traditional loose tube, core alignment, single fiber splice of the 12 fiber. And again, remembering that, buffer tube entry, gel cleaning, of course, shrinking protection sleeves on and routing into a tray was all included. 27 minutes for 12 fibers, 45 minutes for 24 fibers, and an hour and 20 minutes for 48 fibers. And however, we step down now and we see that when we then kind of remove some of those aspects of, okay, now I'm going to use a stranded cable, but it doesn't have gel. I'm going to ribbonize, of course, with the latest generation, ribbonizing tools and mass fusion splice. Now we're at 8 minutes and 10 seconds for 12 fibers, 15 for 24, and only 32 minutes for 48. And then even better still, whenever I'm using these collapsible ribbon cables and a mass fusion splice, 2 minutes, 51 seconds for a 12 fiber splice, 5:45 for 24 and 48 fibers 9 minutes, 20 seconds for 48 fibers. And so that's kind of the key, thing there to look at those differences in times. And the bottom graph might be a little confusing. I apologize, but the gist there is that if, I call my single fiber splicing, 100%, my baseline, if you will, I only spent 10% of the amount of time somebody else did single fiber splicing to do the same strand count, with a collapsible ribbon and mass fusion splice, 10% of the time. So 89.7% time savings on a 12 fiber. And so you can kind of see as that scales and the 24, the 48. And so again, time savings just get pretty massive. So a couple key observations, at least in our study, as I'm sure if you've done it yourself, gel cleaning is very cumbersome. The time specifically for gel cleaning wasn't captured, but removal of buffer tubes, sorting of binders, and gel cleaning was kind of roughly 5 to 6 minutes for the 12 fiber trial. Scales a little bit, if you got more buffer tubes, more gel to clean. However, the collapsible ribbon prep was greatly reduced to not having these things, no buffer tube, no gel. Again, just a lot of time savings there. So now then we get into the inside plant. And so now we're going the splicing of the single fiber to a single fiber cassette, like an LGX 118 form factor cassette. And then we ribbonize to a ribbon cassette. And then again, just collapsible ribbon, mass fusion to a ribbon cassette as well. So here we see a huge jump, of course, from that stranded cassette. So this is like a 900 micron tight buffer. And that's something there, I think, in my key observations I mentioned. No, I don't. But the stranded cassettes, especially in the LGX 118 form factors, are all using like a 900 tight buffer. And folks do that for added fiber protection. But I would say that I would greatly argue that's really not needed, especially with an enclosed covered cassette. You kind of set and forget this after it's done, assuming no drastic damages to the closet or the equipment inside. And so that stripping away and prepping of that 900 micron added time into that stranded cassette termination, the 29 minutes for a 12 fiber one. But then whenever I don't have to prep and splice 12 individual fibers or 24 times, and so now I'm going to ribbonize my left side and I'm going to splice to my pre-stubbed 12 fiber ribbon in my cassette, which is this middle option here of 9 minutes and 30 seconds. And then even better still, the collapsible ribbon, trunk cabled my ribbon or splice cassette again. So not as much savings there. Really, the only savings from that side of things is just, the kind of 2 minutes and some change savings is just not having to ribbonize my trunk cable side and being able to just, grab the ribbon, put it in the holder and splice. And so the bulk of the time for the 9 minutes or 7 minutes is really in like your cassette prep, routing it all once you're done. And putting it into, whatever your panel solution might be. And so then similar kind of graph down at the bottom, as far as translated the percent of time required. So it only took me 24% to do a ribbon, collapsible ribbon splice to a ribbon cassette that it did of the stranded cassette. So again, just huge time savings kind of on all sides. So let's do a run rate example. So as far as if you want to kind of run rate this out and say, okay, we'll take some of your time savings and try to plug this into my real world. So we're going to take a simple example to kind of go back to that campus environment we talked about earlier on. So I've got a 144 fiber ring, let's say. I've got 5 48 fiber mid sheets, and then I've got 4 12 fiber terminations at each of those branches, at each building. So that gives me 18 splice points, and then an option of 432 individual splices or 36 ribbon splices. And again, that's going to be decided on what equipment and cable you chose on the front end. That's 14 hours and 36 minutes versus 2 hours and 22 minutes to mid-sheet and terminate all of those splice points. And so again, 14 and a half hours versus 2 and some change. You know better what you pay in labor than I do. So you can sit there and do the math and calculate your savings on each scenario that for you. So when it comes to testing, some new generation OTDRs offer multi-pulse testing. Sorry, say that 10 times fast. Enabling easy detections of closely spaced events for verification and fault location. So kind of pushing through here. So icon-based user experiences identify events, pass-fail criteria. And so the gist here is that there are some enablements being driven in software, both hardware and software, and your OTDRs to enable, greater speeds when using, a ribbon or an MPO style of testing and form factor in your network. And so, perfect for a data center environment. Of course, that's traditionally been the application, a CO environment. And again, even, maybe, and data center, campus data center-y type of environments. If it's, again, a higher fiber count in each of the buildings, again, you kind of plug these in and just get testing through a lot faster. Integration of external switches. This is an example here, of course, from us. So this is an MPO switch. And so I'm going to be able to scan through and test all 12 fibers kind of with a single push of a button on my OTDR. And it's going to scan through and test all 12 fibers without, manual disconnect, reconnect, setting up and, hitting go on new tests. And so then even an example, there's as I talked about software improvements. So this is an example from AFL called FlexPress. So this is software built into the OTDR. This is ultra fast point-to-point testing. Can reduce your OTDR test times as much as tenfold when paired with the proper switch, of course. And so that's that switch on that last slide you saw there. You're going to have all this combined together. So optimize OTDR settings for fast averaging and reliable fault detection are really what this FlexPress is doing. There might be some really, really low loss splices you might miss, especially if you're in the noise floor .01, or even, some show up as .00 depending on your light source and power meter. But generally speaking, as far as any kind of problems or issues, it's certainly, of course, still going to find that. And, so you look at this table here to look at a dual wavelength test using a standard OTDR and a 12 fiber MPO for, high fiber count cables, golly, just testing alone, 58 hours or 116 hours for these, really high density, high fiber count cables, compared to, 3.2 and 6.4 hours using this, the OTDR plus the switch plus this FlexPress software. That's, again, just all speaking to trying to enable the benefits that, of course, densifying with ribbons, seems to make sense and speak to. So as we wrap up here, just kind of a few concluding points, and I see a couple questions that have come through. I'll answer those, and then any other ones that might make sense. And so 2020, I wouldn't call it a good year. However, it was one to learn and grow from. I'm a personal believer in that, what doesn't kill you makes you stronger. And so, as we look at what has been the challenges of the past year, there are plenty of things to learn and grow from, and I certainly hope that we look to. 2021 has had different challenges, but overall improved. I say that, and we'll see how the rest of the year carries on. And then we learned how to connect despite being physically separate. So we had, again, this challenge of all of a sudden having to shut down and find ways to work and still produce while being sent to our homes and remote locations. However, we adapted much faster than really, I guess, I expected we might have. So, kudos to the human race. Continued development is needed, of course, to improve the pain points discovered in these rapid adaptations. So anytime you have fast change, quick change, large change, you're always going to hit kind of stumbling blocks and pain points along the way. And so there's things, of course, we got to continue to do to address those challenges. Data communications, I think, is going to be a huge enabler to solve some of those pain points and rapid adaptation, growing pains at a large scale. Just this ability to stay connected while we're physically separate, I think is going to continue to be leveraged heavily to solve, various problems. I think we need to rise to meet them in the physical layer with what we can. And I'll close here with this quote that I really appreciate from Albert Einstein, that the measure of intelligence is the ability to change. I really believe in that. I think, folks that are able to adapt and change and do what's needed to, again, meet the new challenges ahead are certainly the ones that are going to excel and bring the greatest level of benefit to those around them. So with that kind of concludes the webinar, the content as I had it pre-scripted. I really appreciate your time. So I'll move into a time of Q&A here. I see a few questions. I'll start off here. So first question from Christian: are MPO one-click cleaners all the same no matter the fiber count? Yes. Actually, I'll have to get back to you on that one. I mentioned I'm the splicer guy, right? I certainly know certain high-level details of a number of these things, but some of the nuanced things I'll certainly look to get back to you answers on. Jason, do most places accept those results the same way they do fluke results? I missed when that question came in. Do most places accept those results the same way they might need some clarification on that one. If you're talking about test results, like when you talk about using like the Flex Express with the OTDR, so all that is really a software that's kind of just increasing the speed of trace data collection. And so you're still going to be collecting the same type of trace file and reporting on that. It's just a matter of speeding up the process to get those. The little handheld tester. Oh, the little inspection scope. Yeah, the little inspection scope. So your question, do most places accept those results the same way they do fluke results? I would certainly think so. I wouldn't imagine. They are testing, of course, each individual fiber to industry standards. I don't know the exact standard per se, but the Focus Lightning is, of course, applying in-face analysis to cleanliness industry standards that are accepted across the board. And so, yeah, I certainly would see no reason why somebody wouldn't accept those. Given an industry governing body is kind of the one saying that it's clean or not. Okay, so Mike, do you know what the lead time is for the spiderweb ribbon compared to conventional ribbon? Great question. I'm not in that side of cable procurement. I'll certainly look to have somebody reach back out to you with those details. If you ask me a splicer, I'll tell you we got plenty of stock. Not so much sure on the cable side, but I'll look to get that question answered for you. Another question from Rick: if you had to do a reburn 2 or 3 times to do out an out spec single fiber, how does that affect the dressing in of the ribbon fiber? Yeah. So if you're talking about, I see what you're saying. Yeah. So say you got one bad fiber and you got to splice it 2 or 3 times. And I guess you're saying that you would do a single fiber splice as opposed to the whole ribbon. So you might have kind of a couple ways I see that. You might have to get a little crafty in your tray. Whether that's, rerouting a sleeve into a different, block in the tray just based on the slack that you have left, or maybe even more simply put, it's probably easier to go ahead and just re-ribbon splice. So that way everything is staying the same length, and you have the same slack on both sides. And so then you can kind of reroute, both sides, in accordance with, I know it's only one fiber that was maybe giving you fits. But a ribbon splice doesn't really take that much more time than a single fiber splice. And so I think just from the sake of ergonomic challenges that you would run into trying to reburn just a single fiber in a ribbon, you might want to just ribbon splice it. And again, if you're doing like a collapsible style ribbon, like a spiderweb ribbon, again, like I said, that's a little easier. You can kind of individually break out that single fiber giving you problems, splice it. And again, you might be able to kind of reroute the slack of that one fiber into a different, wedge or block in your tray. But yeah, if you're like an encapsulated ribbon, that's much more challenging, probably easier to just kind of re-ribbon splice it so you have the same slack. Absolutely. I kind of like this little chat feature, see what you guys are saying in real time. Okay, some good questions. I really appreciate those. I'll mark the ones that I was not able to answer and get back to you at a later date with some of those answers. But any other questions from anybody on any sides of things? I'll certainly answer the best I can. No? Okay. Well, if nobody's got any other questions, I guess we're about, 5 minutes early, so I'll give you 5 minutes back of your life. Thank you so much again, everybody, for taking the time to sit in on this webinar from AFL. This is, of course, recorded as well, so it'll be distributed, so you can kind of save that for future reference of any kind. And I think the resources, the slide deck, and as well as at least something else is in the handout section of this webinar. So you can take that with you, save it for whatever needs you might have, and of course always reach out to your local AFL rep, and we'd be happy to help you do what you do best. I saw one more question. How many burns per electrode? So for a ribbon splicer like a 90R, 1500 is the spec number. I've seen people get a little less and a little more, just depends how daring they are. And there's kind of technical reasons why it's that number. And then for a single fiber, like compared to like a core alignment, it's about 5,000. So certainly a difference in number of burns, but remember you're doing 12 fibers per burn. So 1,500 times 12 is a lot more than 5,000 times 1. So you're still getting a lot more fibers spliced in an electrode life. Good question, though. Have you run into the 0.3? Rick, you got another question. I'll answer this one. How have you run into the 0.3 offset when splicing microfiber to standard SMF? 0.3 offset. 0.3. I assume you mean 0.3 microns of offset. So yeah, when you're looking at that like pre-spliced data, it tells you what your cleave angles are and then what your offsets are. So yeah, certainly. We have folks that run into offsets and call us and they go, "What the heck is going on?" So one thing to remember there is that these V grooves are precision cut to be perfectly aligned one to the other across, from the left to the right. There's a very fine-tuned, well-engineered process by the Japanese to make that happen. And so anything that causes an offset is going to be some sort of physical debris or dirt or foreign substance that's kind of pushing that fiber away from sitting in that V groove just so, whether it's in the V groove itself or it's even in the little white flat clamps that close down onto the fiber V grooves. And so, that's why I talked about earlier, the cleanliness being so important, being able to take the V grooves out of, your splicer and clean. However, as a general rule of thumb, though, 0.3 microns of offset's not that bad. I'd splice that all day long. The mass fusion splicer, the way that it splices, and this is kind of some of the technical nuances, but when you splice those together, there's a self-centering that happens there because it's a longer arc and those fibers kind of want to come together in a line. So we benefit from that, what we call viscous self-centering, as the molten glass seeks to center itself with one another. And so like, for example, 0.3 microns of offset is, again, not hardly anything at all. You're always going to see some level of offset. It's never going to be 0.0 microns of offset. So, I'd be splicing that all day long. Okay. Yeah, absolutely, Rick. All righty. Well, I think that about concludes this. I don't see any other questions coming in here. Again, handouts available to you of the content we went through today. Feel free to reach out to us, AFL, anytime. Again, my name is Lucas Mays, with the Associate Product Manager with the Splicing Group here. We got a great staff of folks looking to support you every day and across all sides of our business. So thank you all, and have a good one.